Hello again, Rob here. We're going to go through a little more simple interest for you now. Hope you've been working through things so far and things have been working out just fine. Today we're going to talk about maturity value. So let's have a look. When a loan or an investment reaches the end of its term, we say that it matures. So really the maturity value is the total of both the original principal plus any interest due on the maturity date. So we've been calculating interest just by itself. Now we're going to look at maturity value, which is both the interest plus the original principal. We also call that the future value. We're going to use the letter S for that because we use it so often we want to give it its own symbol. S stands for subsequent, by the way, which is the old term for maturity. We've changed the word maturity, but we've kept the S. Now the basic formula that we're going to use today is S is equal to P plus I, but I'm going to go a little bit further because we know that I is equal to PRT, isn't it? So I could rewrite the formula like that. Now you might think that looks a little more complicated, but we can go a little bit further than that as well because I can now take the P, write it by itself, and then it's called factoring the P out of there, and then see what's left over. And we end up with P times 1 plus RT. That 1 plus RT, by the way, in finance is called the accumulation factor. Now, I guess you don't really have to know that, but if you're curious or if you come across it, that's what it is. And basically it says if we start with our original principal here, how is it going to accumulate over time to become a greater maturity value? So that's what we want to work with. Now, I'm going to encourage you to work with the red version of the formula there, the final version, rather than anything earlier, because that'll do it in one step for us, which is kind of nice. Let's have a look at a quick example. I'm going to find the maturity value, or the future value, of a $500 investment earning 4% interest per annum or annually for 146 days. So let's have a look at that. Well, first thing I'm going to do is write down everything I've been given. So it's a $500 investment. The original principal is 500, earning 4% for 146 days. Now you could also go 146 over 365 if you want to do the conversion here, or you can wait and do the conversion in the formula. That's fine. Either way is okay by me. What are we looking for? The maturity. So let's go ahead, dig out our new formula. S is P times 1 plus RT. In this case, that's 500 times 1 plus 0.04. And here I'll do my conversion. Convert the days to years by dividing by 365. And I end up with that. And then if I do that calculation, get it all put together, I get $508 exactly. So there we go. That is the original $500 plus $8 interest, essentially. Now, if I had done it, I equals PRT, worked all that out, I would have got $8. I could have then gone and added those two together, get 508. But this is just a little bit quicker, all in one step. And it also leads to some further formulas we're going to use down the road. So I'm going to really encourage you to start working with this one now. Let's give you one to try out. What will the maturity value of $2,500 invested at 4.25% per annum? What will that maturity value be if we invest it from June the 3rd to August the 16th? This time I've given you dates to work with rather than just telling you, right up what the days are. So that'll give you a little more practice on the date feature on your calculator as well. So go ahead and press pause, see if you can work this one out, and when you're ready, press play, and I'll go through it with you. All right, let's have a look. In this case, I'm starting with $2,500 in principal. It's going to be invested at a rate of 0.0425, And the time on this one, 74 days. So there's 74 days between June 3rd and August the 16th. I'm looking for the maturity value. I'll write that down as well. And that kind of leads me into a formula. I do have a formula for S that involves P, R, and T, which are the three things I know. So let's go ahead and plug those numbers in there. 2500 times 1 plus 0.0425. And now I'll convert the time into years as well. And if we go ahead and work all that out, I got $2,521.54. I hope that's what you got, that things worked out okay for you too. Notice the maturity value is always going to be bigger than the original principal P, as long as we're going forward in time with a positive interest rate, of course, which is pretty normal in real life. So we should get a slightly bigger number, shouldn't we? So a few success tips for you again, just to finish things up here today. Make sure you take your time reading the questions. Write down everything that's given to you as well as what you're trying to find, just like I did. Even though these are easier at this point in time, you got to remember at some point they're going to get a little bit harder, aren't they? And if you don't have a good technique on the go, it's easy to get sidetracked or get confused or just not know what to do next. So try to follow the same technique I use. Make sure we're working in consistent units. That's really important when we're solving for R and T. Want to realize what it is we're getting for an answer and how we convert that into something meaningful. Use all the decimals during your calculations. Only round once you get your final answer. And then make sure you also know how to use the date features on your calculator for those questions that you're going to get where they give you dates instead of just days or months or years. All right. That's it for now. Go practice a few of these as well, and I'll see you next time.